Let's move on to our next presenter. It's Thomas Grubb, who will talk about data-driven XR for space missions using NASA open source.
Hey, Frank, thank you.
Hey, Thomas.
I'll turn on my camera, but if we start getting jumpy videos, please let me know and I'll turn off the camera. Okay, good morning, or maybe good evening if you're in Europe or something. Yes, I'm Thomas Grubb. I will be talking about data-driven XR for space missions using NASA open source. I'm gonna have an introduction, talk about the three tools, mostly on the mixed reality exploration toolkit, and then putting it all together in use cases. I've been working at NASA my entire adult life. I was lead on one of the tools, GemSec, back in the early aughts, and then have been the product development lead for Goddard Space Flight Center since 2018. So we started out once the Oculus Rift and all the commodity hardware came about. We started out in 2016, and importantly, we were given a mandate from the beginning to go out and talk to the scientists and engineers at Goddard to see how this newly cheap hardware could help them and benefit them. And we came up with 16 different concepts, pitched the best 6, and then it got funded for the best 5. And why that's important is we did that our first year, and we realized we have a lot of commonality. We kept, the same tools, the same views, everything kept repeating. So we decided after that to make a platform to support all these different concepts. Where I work, it's a collaboration between some center organizations, a couple missions, some universities, and scientists and engineers, and some other centers. So what we wanted to do was help establish the NASA open source ecosystem for XR, to reduce the agency-wide costs and also the long-term risks of this, and hopefully get people more comfortable adopting it. And what we are going towards is a stack of 3 different open source, or NASA open source. There's ARMIT, which is the rapid model import tool, and this came out of KSC, and Jose Chavez is going to be talking about it more this afternoon. And that's for converting CAD models to XR-ready GLTF models, so reduced resolution, throwing away stuff. Then for working with engineering data and telemetry data, we're using the Goddard Mission Services Evolution Center, or GemSec, which is it's a standard for loosely coupled publish subscribe middlewares, and it's now been adopted by OMG. And then finally, the bulk of my talk, as I mentioned, is on Merit, which is hopefully to rapidly build these XR environments for NASA domains. Briefly about ARMIT, as I mentioned, Jose will talk more about it. It leverages Unreal Engine. It's about pulling in CAD models from Creo, Maya, etc., and converting them to GLTF. And it's kind of like an open source alternative to PyXYZ that maybe many of you are familiar with. And we also are working with them to integrate some of their ARMIT stuff into Merit, because Merit has the idea of these CAD models have metadata about them. If it's a part, what's the vendor, what's the description of it, what subsystem is it about, what its mass is, or power consumption. The other standard is this is GemSec. This has been adopted by a lot of mission operations centers. 20 at Goddard Space Flight Center, 10 at Ames, and 10 at Space Force as of the last time I checked. And it's designed to be loosely coupled to enhance integration, to building these mission operations centers, maintaining them over decades sometimes, automating, getting situational awareness of what's happening in there. And it has two important factors. It has a standardized API, so how you code to work with published and subscribed messages, and then standardized messages that describe different components of the Mission Operations Center. But it's not just for mission operations, but it does have wide industry support for mock components. It's, as I mentioned, NASA open source, can use free middlewares as its backbone, or commercial industry middlewares as you need, as you have more performant needs. And finally, the project I'm leading, the Mixed Reality Exploration Toolkit. So it's developed out of Goddard. The whole idea is to try and get away from always having to go back to Unity to do your next project. So it's designed for an end user to rapidly build XR environments for NASA problems. And you define it using a project XML file that defines the environment, what items are in there, what objects, what's 3D, point clouds, terrains, drawings, etc. And it pulls it all together to make a collaborative environment that combines NASA models, whether it's scientific models or point clouds. It's basically point clouds right now. So if you have a scientific model that can output point clouds or LiDAR data, CAD models, you have this common tool set that we used in all of our different concepts that we originally came up, measurement tools, nodes, voice commands, etc., and then access to data sources using GEMSEC. It is now NASA open source. You can get it out at software.nasa.gov or go directly to GitHub. It's primarily VR, but we're starting to roll out support for HoloLens. And our eventual goal is to get parity, but we're far from that at this point. So the highlights, you can combine your 3D models with point clouds and terrains. You can use it in VR. We target like Vive Pro type things. There's also a desktop version and this limited, preview in HoloLens. You can collaborate on secure networks and over VPN. You can drive your models, your 3D models, from real-time telemetry. Because we integrate with GEMSEC and with the robot operating system, ROS, we can actually move the models based upon what telemetry is coming from a satellite, such as the solar panel deploying or joint angles on your robotic arm. We can then drive the model in VR. It's a product-based tool, so everything's defined in your XML and you have that common feature set. It's NASA open source, but there is, it's Unity. There is Unity plugins, a combination of about 14 free and paid plugins. Out on GitHub, you can get the built version, so you don't need those. But if you want to, play and add features, you would need to get these plugins at this point. We work a lot with universities and we leverage our partnership with them. We work with the University of Maryland, Baltimore County, and they've provided Virtual Data Explorer, which I'll briefly talk about, VDE. College Park in Maryland has been looking at supporting different hardware. They helped us get started with ROS. University of North Texas wants to use it as a platform for human factor studies, and that would feed back into our thing. And Johns Hopkins is looking at it as we go more and more into AR, helping us with the user experience. A lot about Merit is integration, GEMSEC, MATLAB, SPICE, which is comes out of JPL. This is a software that says, if I'm on the moon at this location at this time, where's the sun? Where's the Earth? Where's Mars? and it can help you all throughout the solar system. And obviously, this would be important for environments where you're supposed to be on a planetary area. VDE, as I mentioned, Ross, ARMIT. We're looking to integrate with the NASA Internet of Things platform that Jeff Brandt is working on, and he's talking about tomorrow. And eventually with something that I don't know if Frank's going to talk about, we're working on a 3D shared object repo as well. I've mentioned GEMSEC a bunch of times, so it's important to describe what it is. So as I mentioned, it's a middleware for communication. It defines a standard API and messages for different components. This means that you can rapidly build a mission operations center by saying, okay, I want to use this telemetry and commanding system. I want to use this flight dynamic system, et cetera. And I want to use this certain middleware. And by using these standards, you can then go, okay, I want to swap out this telemetry and commanding system for a different one. It's been 10 years, it's way out of date, whatever. And you can even swap out the underlying communication middleware. So as you're in testing, you can use free middlewares. As you go to production, you can use an expensive vendor one. Now, what we did is we said, okay, let's make Merit GEMSEC compliant. This has a couple advantages. The first one is that we can then subscribe to telemetry that's coming from the satellite or instrument, or any telemetry that's posted by any application, and drive our models. Plus, we actually use GEMSEC as our communication middleware for collaboration. This is important because we can actually use it in a secure environment over VPN. GEMSEC has authority to operate, as I mentioned, in 40 different mocks between Goddard, Ames, and Space Force. And we're looking to keep integrating, as I've mentioned already, GEMSEC, ROS, and Internet of Things. I won't talk more about those. And the whole idea is we want to reduce the cost, risk, and barrier to access XR. This whole solution, we want to use ARMIT so we can get 3D models into XR without, a startup cost. Get the data over GEMSEC or ROS or eventually IoT, and we can also collaborate over GEMSEC. Now we put that all together, and we can provide lots of use cases out of the box, from the beginning of the space mission lifecycle of concept design to hardware integration and test, situational awareness during operations, to looking at science visualization, point clouds or terrains. Common thread, all of you know this, collaboration is kind of the killer app, if you will, of XR, being able to get these dispersed groups to be able to work together in a shared 3D space, and helping us in this time of pandemic. So different, briefly, just showing some videos, concept design. So we can be pointed to a directory of different 3D objects and parts and have that description I mentioned earlier about ARMIT. So you could quickly put together, we provide a CubeSat design, and you could put together your CubeSat, just a rough cut, because we track mass and power consumption, we can do these master equipment lists and get you the, what's the mass of your CubeSat, what's its peak and average power, that type of stuff. You can, of course, do the standard kind of SDK type of visualizations, because we've driven from telemetry from GEMSEC and ROS. We can visualize the spacecraft and its instruments, where they are in orbit, pass information, their connections to different ground stations, the instrument swaths and views. We can even, because we have the globe and we have what the camera is looking at, we can show you, as here, what if it was a camera in the visual range, what it's looking at. You can do more spacecraft situational awareness. So in the bottom right, what you're seeing here on the left of the bottom right is OSAM-1. It's going to be a servicing mission. It's going to go up to Landsat 7, the gold foil satellite, grab it with a robotic arm, pull it close, peel off an area and refuel it. And we can drive what the robotic arm is doing in real time or within the tolerances of TDRS, 4 to 5 seconds, 6 seconds, what's happening. So this really helps us, get an intuitive comprehension of what's happening, procedures, depths, clearances, etc., and give you a nice situational awareness. The video at the top is something that a Johns Hopkins University is working on, which they call augmented virtuality. So they are going to take camera data that's going to come down from OSAM-1 and use that as a texture on top of 3D objects. So you can get the accurate lighting that's actually occurring in orbit using that. And that's something we hope to integrate one day before it goes up. You can get more in-depth situational awareness. We've tied the telemetry to different parts, and we can show red and yellow limit violations. So here it's just simulated telemetry, and as things go in and out of limits, they change their colors. And you could imagine if we combine this with the ability to get archive data, this could be a very important tool for analysis to understand the cascading series of events of what's happening or what happened during that problem in orbit. Hardware integration and test. We've talked about it a bunch of times. You can do things like your planning, your fit checks, reach and access. We can actually draw cables and do measurements. It would help with, training, etc. And the idea being that we'd start in the virtual world in VR, take that same project and eventually use it, as we transition to supporting HoloLens, that, okay, we planned this all out in VR. Now we have access to the chambers, but we don't have access to the hardware yet. Well, we can start combining them. And then once we have access to both of them at the actual hardware integration and test, we could use that to help with procedures. Or even if they published telemetry about, from a GSE or whatever, you could use that to overlay on what they're looking at. I mentioned Virtual Data Explorer out of UMBC. This was originally a Army Research Lab funded project that was open source, and UMBC has now integrated that into Merit, and it provides a network topology visualization tool. So as you get closer to different nodes on your network, you get more information. You can grab a node, move it around to see what to use your spatial depth perception to see the connections to other nodes more accurately. And VDE, before integrating with Merit, has been used in different NATO exercises for their NATO Cooperative Cyber Defense Center of Excellence Cyber Defense Exercises. Big breath there. And we hope, as we've added it to Merit, it will be used in future NATO exercises. So on the science side, we've done stuff like take lunar terrain. We took LOLA data and we visualize what's happening at the lunar South Pole. And what you're seeing in the top right is 30 days. And at the end in December, what if you were at this location on the moon, what the sun is going to be doing, and the long shadows you're going to be seeing at that time. This is not ray traced at this point. This was before we started going to the high definition render pipeline that Unity provides, which you could do ray tracing, but it was very good visualization to see those shadows, how they would affect solar panels or power consumption, or where permanently shadowed regions, etc. And it was retweeted by Buzz Aldrin, which was a highlight of my NASA career. And this is not showing actually something for Merit. This was one of the ones before Merit, but point clouds are something that look really easy to understand in VR. You can get a real sense of their structure. And if you get enough points like you're seeing right here and color them with natural lighting, it can almost look like a photograph. And the idea being that you could revisit spaces. You could get LiDAR data of your lava tube out at in Iceland, or Craters of the Moon National Monument, and allow the scientists to revisit those sites that are difficult to get to, or they don't have funding to go back to, etc. This is another one that was before integration of Merit, but we are adding this. You can animate the point clouds. So some astrophysicists wanted to look for moving star groups. These are groups of stars that are moving together. And if you can find these groups, you can say, okay, I know where they're going. I see them. I can trace back to their common start point, and I know how fast they're moving. I can figure out how old they are, and we can use this for exoplanet search. And what we did is we hooked up with an ESA satellite, Gaia data. At the time, they're DR2, and allowed the user to be able to scrub forwards and backwards in time to take advantage of our ability to see these spatial relationships, especially as they move, and help them in their moving star groups search. And they did find some important information, and they've just been accepted to be published with their data using this tool. I think I can skip most of this. I think most people here understand how XR has a lot of advantages, but it can be a valuable tool throughout the NASA open source pipeline throughout our mission lifecycle by combining 3D models, terrains, point clouds, and then combining that with telemetry. And by being open source, reducing that cost and risk, and hopefully getting contributions such as what UMBC has done to help everyone. And that's it. Are there any questions?
It's simple.
The challenges. The first one that comes up is that you have to find a funding model that works. Open source doesn't necessarily fund you. What we're trying to do is have this mixture of funding from organizations, from missions, to leverage, to take Peter to also help Paul, not to steal from one to the other, to leverage the commonality so we can help everyone, and then, feedback and do mission specific features as they, as they need it and they fund it. Other challenges, just our procurement and approval process. Like we could, I think this has changed, and Frank just mentioned this a few weeks back, that we couldn't use Quest 2s for a long time because they are made in China. So we can't, supporting all these different devices just isn't possible for us. However, we were able to leverage University of Maryland, College Park, and they said, okay, we'll try it, and we can buy Quest 2s, and we made it work, and we can give you feedback on what will help you. So navigating our approval process and procurement process is always a challenge, and becomes a little bit harder in the open source world.
Yeah, and it looks like David has his hand up.
Yeah, I noticed when you were talking about ARMIT, it said it needed Blender and Unreal, and yet
Yes.
the MRET is built on Unity. So could you talk about that a little bit?
Sure.
In terms of,
So it's really ARMIT is a preprocessor for Merit. What's a good slide? So, here. So the idea is that ARMIT can run, and it's usually in batch, and take your 3D CAD models and create lower resolution models. And we're using it locally, but there's a push to add it as a function as part of this 3D object share repo. But they will generate files that you then say in Merit, I define my project and I say, okay, I want this environment, but I also want that file. I want that converted, in this case, Hubble Space Telescope, and pull it in. So they don't need to be talking directly to each other.
okay. So you create the GLTF and then you can use that inside of your Unity
Inside of Merit. Yeah, Merit.
Inside of Merit.
Yes.
Okay, thank you.
Mm-hmm.
All right, do we have any other questions around the loop? All right, doesn't sound like it. So thank you. Excellent presentation, and definitely agree with all your comments on the challenges to implementing actually any XR system. I think at NASA faces those